Once again, when we're doing this, we are going to be working with a right triangle, just like we were in the Pythagorean theorem. Now, a right triangle is going to have two angles that we care about. By the way, when we have a right triangle, when we talk about angles, we're not going to talk about this guy right here. That guy is always 90, so we have no questions about it, so we don't ever really look at that angle. Instead, we have two other angles. We have this one and we have this one. Now, either one could be our angle, and it's actually really important you know which one. Now, let's say that I put the angle right here. Okay. By the way, I'm using a symbol. You'll see these symbols right here. That is called theta. It's the Greek letter, and it's what we use for a variable for angles. It's just typically what we use instead of x. But a lot of times you will see x also. Now, once again, you know already that we have a leg, and then the hypotenuse. And the hypotenuse is going to stay hypotenuse. Okay. But instead of legs, we're going to use the word adjacent and opposite. Now I'm writing off to the side because that's going to switch depending on where your angle is. See, the word adjacent means next to. And so when I see this angle right here, the side that is adjacent is the side that's next to that angle. So this one right here would be adjacent. But if I was to draw this one and I put my angle here, then this side would be adjacent because that's the side next to it. And then opposite would be the side opposite the angle, so across from the angle. So this one's the opposite for that angle. But on the bottom one, if I was looking at that angle there, this would be the opposite. So it all depends on where your angle is, which is why it's really important that you look at where your angle is and compare. Now, sine, cosine, and tangent are really just fractions. That's all they are. Just a fraction. And so if we have sides, let's just be simple here. So 3, 4, and 5. So if we have our three sides, and I want to know the sine of theta, okay, once again, I'm looking at that here's my angle. So I have my adjacent, my opposite, and my hypotenuse. And I have that sine, so sine is the opposite over the hypotenuse. So sine is opposite over hypotenuse. So that's something you need to memorize. So then my opposite side would be the one opposite the angle, which is 4, and my hypotenuse is what's always my hypotenuse, and in this case it's going to be a 5. And so that's the sine of our angle. Cosine of the angle is always the adjacent over the hypotenuse. So my adjacent side to the angle is 3 this time, and the hypotenuse again is 5. Again, it's just coming up with the fraction. Tangent is going to be the opposite over the adjacent. And so in this one, tangent, the opposite is 4, the adjacent is 3, and so there's your fraction. Now that's a pretty basic look at trig functions. We can also look at some other things. So let's say I have an angle here, or a triangle here. And my angle, let's see here, I'm going to put an angle in there, 30 degrees. And I know that, let's say I know that this side right here, the opposite side, is 4, and I want to find the hypotenuse. Okay, so whenever this happens, you need to first, draw it out. It's always draw it out. There's no getting around that here. Okay, draw it out. Look at your sides. Identify what sides you have and what sides you're trying to find, because that's going to tell you whether you're going to use sine, cosine, or tangent. Since I have the opposite and I'm trying to find the hypotenuse, I'm going to be using sine. Okay. Then I plug in what I know. I know that my angle is 30 degrees, so I'm going to write sine of 30 degrees equals my opposite, which is 4, and my hypotenuse, which is x. And now I want to solve for x. So you're either going to be given a table to know what this is, the sine of 30 degrees, or you're going to use your calculator, make sure your calculator is in degrees, and you're going to plug that in. And so when you do, you're going to find the sine of 30 degrees is 0.5. Okay, and now we solve for x. I want you to be careful. Notice where the x is. In this case, the x is in the bottom. I want to solve it so that x is not in the bottom. So the first thing I'm going to do is I'm going to get x out of the bottom. Because it's in the bottom, we're dividing. So I'm actually going to multiply by x on both sides. And so now we have 0.5x equals 4. And then I want to solve for x, so I divide by 0.5. So now x equals 8. So my hypotenuse is 8 units, whatever that unit was.